Okay, welcome to vlog 60. And in this one, we're going to do a tour of the latest updates to the MotorDoc Empower. In particular, there's two features we added. It was at the request of a project that we have for a customer. In this case, they needed periodic testing. This is a step towards the continuous monitoring version of the Empower that will be available by summer of 2025. We're doing testing now and selecting optimal components and stuff like that. So, but in the meantime, because this has applications for wind turbines where data collection is needed up tower where you cannot be when the machine is running, let alone other applications where you just want to set down a laptop and your Empower system and let it run. Now we do have some capabilities. If requested, there's things we can provide that will, basically small mini computers you can set up to do the data collection, that kind of thing. But usually you would use your laptop, you would set it up, and you would allow it to run. The Empower remains the only commercially available device for regular industrial and commercial applications that has any supra-harmonics capability. In this case, it's from 2 kilohertz to 22 kilohertz. This is for unusual applications. It does meet 61000-3-40, but it is limited to 22 kilohertz right now. We are looking down the road at a full range, 2 kilohertz to 150 kilohertz. We've been working on this for some time. It's apparently a new concept to the industry. We've actually been looking at it, so we have an idea of what the impacts are. And as a matter of fact, not in 61, but in our podcast 62, so 2 weeks out, we will be covering a field test in a cryptocurrency site on supra-harmonics. So we have all of this stuff going on, all off of single phase of current. So let's get going. So this is a background screen. This is normally disappeared by most software when it's an application. This is the startup. This is a special application, and for those who love AI, yes, one of our programmers was ChatGPT, as well as several other AI-based support systems for software programming. So the end result was a lot of documentation, a lot of other capabilities. We had our experts working on it and everything else. So here's the system. You'll notice there's a new button on the front. We moved the date of the data file over and out of the way. This is what we released the last time. This is the bearing database of 83,000 plus bearings that we've collected since 2000, actually 99. But so it basically has almost anything that you would have. So the new addition here as well is this button here, DFIG wind turbine. So this is for DFIG capabilities. We're going to have other wind turbine types in the next version. This does not say we are not still recommending empath systems for wind turbines. The empath system runs in the mid 20,000 range, and it is fully capable of detecting the entire powertrain of a wind turbine. As a matter of fact, the Gearbox Playbook for American Clean Power, formerly American Wind Energy Association, includes a section in there because of how accurate the empath and ECMS E1s are. We are still evaluating this, but the rules that we have found over time, based upon all the data we've received, which is over 6,000 turbines that we have actually analyzed internally, that's individual turbines, multiple data sets, basically gave us the ability to make some changes here that allow us to do things. So a lot of this stuff happens in the background. There's some tweaking we're going to have before the March official full release, which will also provide information on the severity of a defect with, say, a wye-ring. Okay, so basically the scoring system we had been providing of C, D, and F will be included in our software. That means, because people were relying on myself and my people, but it'll be MotorDoc's brain in a box. Here is the harmonics. We added this in this coupling and driven section. Direct drive belt application. Because I'm kind of talking about gearbox, right now you can use it for a gearbox up to the middle stage. We still have to, and we'll have this for March. We are going to include one that's a sun gear, a planetary gear set for wind turbines, and that will probably replace either this stage here or we'll include it as an extra. This is set up uniquely in that as it goes through the teeth and ratios, it will adjust the speeds for all of the bearings in addition to what's going on with the gears. So it's made it a very, very powerful tool. I've used it a couple of times for that already, but that's all present there. And if we have a gearbox and we want to include the main bearings, we just use the pump and fan section as well, and then it'll take all of those speeds all the way down to the output speed here, or input speed in a wind turbine, and then we would take these two bearings and make those the main bearings, and we can even put in a 3 here for the blades on the turbine, and that will evaluate everything out to the blades. So we've already built that in. That was our original design, as a matter of fact, because all of this has been planned out through 2025. What I'm about to show you is the early release of a capability that we had already planned, so it was already in process. We just finalized it so we can make it available. So all of our present users will have this availability if they wish, and this is how it goes. So what we do in here, new analysis, basically, we'll start collecting data. We're not going to touch that yet. This is all the rest of it. So I have the system hooked up to a special setup we have for, basically I'm going to monitor the laptop. We're going to pretend the laptop's an electric machine. So let's go ahead. We set up the nameplate. I'm just going to leave these defaults in here. Settings, this is the sensitivity for the device I'm using. Don't worry about this. This is not functional until we get the continuous monitoring system working. That'll be the summer. We just have those there right now as placeholders. So we're at 100 millivolts per amp, but for fun, I'm going to leave it at 10 millivolts per amp so it exaggerates our test results. And then this one here is a CT ratio, so let's put in, say, because we're talking about wind turbines, we'll say it's a 3 conductor, so we're going to put one current clamp around one of the 3 conductors. Right now we'll leave all these there. In the final version, we're going to be making adjustments to these as part of it. However, what we did release in version 1.1 is that these auto-adjust. So these adjust from their values based upon where the noise floor is. So you leave in your defaults, and if you have a high noise floor, say dirty power or something like that, that results in your dB going only to -50 or -60, it will adjust those accordingly per a set of rules. So that's a quick tour. Additional data, this is actually, we use this for part of the analysis. We'll cover that later. This will end up looking more or less like vibration data. As you can tell, blank everything initially. So let's go ahead and we're going to use that back here. And for fun, we'll just call it a DFIG. And we're going to save that nameplate. And we're going to create a new one that we're going to do all of our stuff in today. Okay, and then we are going to call this, you notice it's a JSON file, very simple. You can open this in Notepad if you want. Take a look what's in there. So we're going to say pretend wind. Okay, so whatever we want to call it, we put it in there. We can also pull it from another section. We can copy and paste them in there, whatever we want. Now this data is here. Pretend turbine. Well, I probably should have done this before, but let's say it's a 1 megawatt, 1200 RPM, 60 hertz, 690, which is common for a wind turbine. The full load current for 1200, let's say 950. We'll worry about that stuff later. Annual operating hours, we'll say 3,000. And then cost per kilowatt hour, just because I like simple, we'll call it 10 cents. Let's say this one has, similar to some other ones, 54 rotor bars and 90 stator slots for 12. Yeah, that's about right. Let's say this is 3.121. I'm just going to randomly select, but I could go into the bearing database here and tell it it's SKF 330 M, and so let's use this. Okay, so we'll call it a 3.588. 5.412, 0.399, 2.366. I do have to fill in all of these. So even if it's two sets of 6330s, I still have to have it here. If I leave one out, it will not run the bearing. So that will be corrected in time for the March release. So if you have both bearings are identical, you only have to put one in. So I have this set for DFIG. These are all placeholders right now. Let's make sure we got everything else. We don't have to do anything in there right now. We've got this all set. Let's go back here. We're going to go ahead and select New Analysis. Here we go. You notice the current looks high, and that's deliberate because I've set this up so that it will read that high. The wave shape is correct for the laptop. So we're going to go ahead and collect it. I will pause the recording while it's collecting because this is 120 seconds or 2 minutes. And really, I'll just put you to sleep. So let's go ahead. We'll click on this. And we will save the data. There we go. Into there. And I will pause. Okay, so we're almost down to 0. And then it's going to run everything in the background. So we're going to run this as new data instead of what I've done before, just pulling up data. I managed to get my system to be able to record this and that at the same time. And hopefully, actually, I didn't check to make sure I don't have, so you're not listening to the electrical noise in the background. So once this is here, I can save it. Now, this is one direction. I'll show you the data collection afterwards. So what's happening right now is you'll notice this is starting to populate here because I'm running so many things running a little slow. But it's selecting my line frequency. It's selecting everything else. It's going to pretend that this is a 1200 RPM wind turbine. So when I had checked that box, it's going to look at an asynchronous generator. Okay, so here we go. We have this, and it's all garbage, by the way. So this is not really a wind turbine. So let's go ahead. We'll hit Auto Analyze. Now this is, there's a little box that's popped up that I can't seem to drag over, but that tells me it's going to take a little time. And it started doing the analysis. It's already picked the speed. I'm sorry, it hasn't picked the speed. It's doing a kind of a robust thing. So we are, for the next version, we are going to have the speedier data selection again. So we got a little more accuracy again, slowed things down a bit. We're going to speed it back up again. Might even have that in this Friday's official release, or Thursday, I should say, official release. But that's the one where it instantaneously does it. So right now it's picking stuff, and then it will start getting ready to populate all the conditions and what it sees. Now here, it's going to tell me the condition of the wye-ring, or actually it's going to identify if there's a wye-ring or slip ring issue. It's going to call both, because we do know that slip rings can emulate a wye-ring issue. So if it says slip ring first, then wye-ring, that means it's most likely a slip ring. If it says wye-ring or slip ring, then it's most likely the wye-ring. And then on the first week of March, because we're working on putting the alert levels into the software right now, it's all commented out, but it will actually look at the values of both and make a call based upon the severity. Okay, and there we go. It's doing right now is calculating all the lines and all the values, comparing them against the alarms, and then it'll populate the screen and give us a condition. Okay, almost there. This is the last part here with the spectra for the estimated kilowatts. There we go. Okay, calls check slip ring or slip rings and wye-rings. So yep, it's taking a look at specific things. There we go. It's set up everything the way it should. And now we can also take a look here at the kilowatt spectra. Okay, so there we go, and this allows us, of course, to zoom into conditions. So if we want to go in here and see where the lines are, we can do that. See all the peaks that are lining up and everything else. There's our speed peak. And then additional data, this actually gives us everything. So there's the pull pass frequency value, there's our speed and what the watts are at that speed. And we go down for all of the different losses for each of the conditions. Now, it's exaggerated because of the way I set it up. These values will not normally be that high. So this is the end, so it's 6.6 kilowatts. These are all watts. If I analyze, it will calculate out the total consumption and everything else if it was a machine. But basically, if I'm troubleshooting, I want to take a look here. So there's my pole pass frequency for the wind turbine. There's the speed that it's selected. And then, that's because I have it checked there. And if I come in here, I can see what our supra-harmonics look like, just by checking this box and hitting Analyze. And there it goes. It's going to give me some values down here when it's done. So here we go. This is supra-harmonics in dB out to 22 kilohertz. Okay, and you notice that the X and Y, so my frequency and my value in dB, show up in the brackets to the lower right. I can also save this image to where I want in whatever position I have it, right? So let's go ahead and we're going to take a look at what the current waveform looked like. Here's our current waveform. And if we want to dig in, we just come right in. That's what the waveform looks like. And then let's take a look and see what the harmonics look like, including all the way out to the 367th. So here's the first values in actual current. So the third harmonic's about 27, which is what I'm expecting, because in reality this is here. So here's our harmonic analysis. Okay, so this is all per, the first 50 is per IEEE 519. Everything else is, there is no standard yet. Hopefully we cover it under the new version of 519. There is some discussion in 1547, the 1547 series and the 6800, or I'm sorry, the 2800 IEEE standards, which are for clean power applications. But of course I'm in single phase, so I'm expecting this primarily. There is some 5th and 7th, of course. If I type this up here and save the PDF, that will allow me to save these 3 images in whatever notes I put here as a report document. We're not going to do that. So close these, close, and then get rid of this. This could be closed whenever. There's space on there for a reason. We're going to have the motor database in there eventually. Now, if you're an existing user, that motor database is available to you as an Excel spreadsheet. But for convenience, we'll end up building that in there. It will also do certain estimations. The idea is to help you walk through what your rotor bars and stator slots really are based upon the data. That will be later this year. So this is all of this capability here now for that. So just like an electric machine, now if this was an actual electric motor that was 1200 RPM, this value would be under 1200 RPM. But most generators overdrive if they're asynchronous, so that's what that is. So let's go ahead. What we're going to do is I'm going to set up data collection. And just so that we can do this relatively quickly, I'm going to leave this at every 5 minutes. So if I need to leave my laptop and whatever somewhere for safety reasons, I have to put it in a cabinet, whatever, I can put the laptop and that device, or any type of small mini computer is perfectly fine. Single board computers work too. Those are popular and inexpensive. But I can put that right in the cabinet, put one current clamp on, whatever, start the thing up. That way I don't have to expose anybody. And when I hit start, it's going to start. Okay, and it's going to ask me where I want to save it. So let's go ahead. We're going to save it into that folder. And we're going to use this nameplate data. And we're just going to let it run. So here it is. Data collection every 5 minutes. It will do it from 5 minutes after the last data collection. So if I put it in and I say 5 minutes, then the first one will happen then basically from the very first test, 7 minutes later, it's going to get the next one. So I'm going to pause. Let me go ahead, though. I'm going to see where this pops up. Here we go. And I'll show you what's happening already. Try to show you what's happening already. Hold on a sec. Windows is okay. So that just took a few minutes. So I'm going to come back and I'm going to check on this in just a little bit. Okay. So for this, we went ahead now and we have 2 in here. I'm going to have to go back and do some editing, but we've got 2 sets of data in here. So let's go ahead and we'll just grab the second set of data when we go in there. So we're going to stop it. Okay. Unless it's collecting data again, which apparently it probably is. Yeah, it is. So it'll allow me to stop as soon as it finishes collecting data. Pending 21. It's 26, so it's collecting data right now. Oh, there we go. We've stopped it now too. So it waited until it was finished. So you can see that it is down here going to have collected another set of data which should populate. Let's go ahead and close this now. And I'm going to exit out of here while it's doing what it's doing. Let's go ahead and we'll open this third set of data, because I don't know what it did. Oh, 15 megabyte, that's about right. Pretend wind. See, it's doing everything in the background, and we'll be right back where we were when we started. So that is some of the capabilities of the system. If I then come in here and take a look and set up all the screens the way I want, save PDF, it will create a report, and that'll include everything that ends up down in here when I run the analysis. So if I do run the analysis and I want to add anything or subtract, edit this area here, I can do that. And the same thing happens in the additional data section with the watts. If I think something's way out of whack, I can delete that and I can subtract the number and run the analysis based on the total. So when we run that energy analysis, it comes off the total at the bottom. So wherever it says total equals blah, that blah becomes that analysis. And here we go. There we are, right back where we started. And with that, if you have any questions or you're interested in the Empower system and these capabilities, reach out to us for a quote or for more information. Note that when you purchase it, you get the updates. So everything I'm showing you now isn't something that's sold to our existing users. They get to go and update it off of a website. They can download this stuff directly. And once they've licensed that first version, when you launch the new version, it just picks up off that license. With that, have a great day.